on. Let me open up this textbook. Sorry. So we started a new unit thing.
Okay.
All right. So the first problem is sorry. 3 3 exponent 3 times 3 to the second exponent. Is that what?
Like that?
Yeah, I think that's right.
Okay. What do you do when the base is the same and the exponents are different? What do you do to the exponents?
You add them.
Okay, so it's the same base. That's how you do it.
Okay.
And if I had this, I subtract them.
Okay.
And if I had this, I multiply them. Those are your 3 rules of dealing with exponents.
Okay.
Okay, what else you got? I'll leave those up there for a moment. We'll write over here on the right side.
Okay. My next one is parentheses 2 to the 4th, and then close them, and then it's squared.
Okay, what's that? Based on my 3 rules.
It is 8.
Give me the final answer.
2 to the 8th.
Okay, good. What else you got?
Let's see. 9. So parentheses 2/7, and then close them, and then negative cubed outside of the parentheses.
Okay. It's a negative.
So,
And they just want you to simplify this?
it says evaluate the expression, tell which properties of exponents you used.
Okay. First of all, let's talk about a negative exponent. What does a negative exponent mean? If I said to you this, what does that equal to?
That is equal to 9.
Nope. It's 1 over 3 squared. In other words, the meaning of a negative exponent is you take the reciprocal of the positive exponent, which is 1/9.
Okay.
Okay? And it turns out that when you have a negative exponent, let's say I had something like this. If you have a negative exponent, all you have to do is move everything to the other side of the fraction bar and change the exponent. So 1 over 4 to the minus 2 would be the same as 4 squared, or 16.
Okay.
Okay? Therefore, on this problem we have, is all we have to do is reciprocate it. We have to move each number to the other side of the fraction bar and change the sign of the exponent.
Okay.
Now, 7 cubed, what is 7 cubed? 343 all over 2 cubed, which is 8. There's your answer.
Okay. All right. The next one is so parentheses 2/3, and then close them, and then it's to the negative fifth power.
Fifth? Okay.
Yeah, and then we have a new parentheses with 2/3 in it, and then close them, and it's to the fourth for that one.
Okay.
That's it.
Well, this is multiplication. It's also same base, 2/3, 2/3. So when you have multiplication and you have the same base, what do? If I have b to the x times b to the y, what does that equal to? B to what?
B to the
What do you do to the exponents when you're multiplying the bases?
add them.
Okay, that's exactly correct. So that's what we have over here. We have same base, different exponents. So what does that equal to?
So
Base
that
doesn't
is
change, so let's just write the base.
it's just -1.
Okay, now simplify that, because usually they don't want answers with negative exponents. They can certainly give you problems with negative exponents, but they usually say all answers should have positive exponents. So what's this equal to?
It's equal to. I'm not really.
Flip it.
That's all I have to do. Oh,
Yeah.
yeah. Okay, I remember now.
Here's the reason why. Is because when I see that, it's the same as this. 1 over 2/3 to the positive 1. That's what it means. And when I divide 1 by 2/3, I flip the denominator and I multiply and I get that. But the real key is that when you have a negative exponent, especially a fraction, so all you got to do is reciprocate it. You got to flip it, and you'll and to the positive exponent. In other words, if that was that, then it would be 3/2 squared. Got it?
Okay.
Okay.
The next one is 17. Okay. So in parentheses we have 6.3 times 10 to the fifth, and then in the new parentheses we have 8.9 times 10 to the -12th.
All right. These look harder than they are. Okay? You multiply that part together, and then you multiply that part together. And that's your answer. So using your calculator, tell me what 6.3 times 8.9 is.
And I'm writing down. Okay, with the calculator, you want me to tell you what 6.3 times 8.9 is?
Yeah.
6.3 times.
In other words, this isn't a problem I would expect you to do manually. This is a calculator problem.
56.
What is it?
56.07.
Okay. And times 10 to the what? When you multiply that times that, what do you get? Remember, same base, different exponents. What do?
Add the exponents.
Okay.
So that's 100 to the -7th.
It's 10 to the -7th.
Oh, yeah.
Not 100. It's the same base.
Same base, yeah.
Always the same base. Remember, b to the x times b to the y is b. It's not b squared or 2b. It's b.
Yeah.
So
Okay.
you have the same base. with various procedures, your base stays the same. Okay? Now, there's nothing wrong with that as an answer. But it isn't scientific notation.
Okay.
Okay? If they just gave you that problem, then this answer is fine. If they gave you that problem and said, put your answer in scientific notation, then you have to convert this.
Okay.
Now, how do you convert it? Well, if I move this decimal point, scientific notation, I don't know if that's the problem or not. Is it? Are you supposed to put it in scientific notation?
Oh, yeah.
Oh,
Yeah, we are.
if you are, well, then this number has to be between 1 and 10.
Okay.
So I need to move that decimal point one spot to the left to give me this answer. And since I basically moved it to the left, then this is going to be one more.
Okay.
Now, that can be confusing as to which way you move it. Okay, let's talk about that. In other words, we know that every spot we move the decimal point causes this exponent to change by 1. But what frequently is confusing is which way. Because sometimes we have to go the other way. Sometimes we have to move the decimal point to the right and subtract 1 from the exponent. So let's figure out how to figure out when we forget. Okay? If I say 11 times 10 to the first, what number is that?
It is 11.
Nope.
Oh, wait, no, it's
10 to the first is what?
To the first, that's 10 times 100.
No, 10 to the first, not 10 to the second. 10 to the second would be 10 times 10. 10 to the
Oh,
first
okay.
is 10.
All right.
So what is 11 times 10 to the first?
It is 105 to the first.
It's 100.
110.
When you multiply a number by 10, you just add a 0 to it.
Okay.
Multiplying 11 by the number 10, I'm adding a 0 to it.
All right.
Okay. Now, if I wanted to put that in scientific notation, I know this 11 has to be a number between 1 and 10. So the decimal point was there. I got to move it to the left one. And now, what would I have to make the exponent to make this thing equal 110?
Add 1 to
Exactly. In other words, 1.1 times, this is 100, equals 110. So this gives us our rule. In other words, it's very easy to forget a rule when sometimes it goes opposite than the other. Okay? So when I'm moving my decimal point to the left one spot, I add 1 to the exponent. That's the rule. If I'm moving my decimal point to the right one spot, I subtract 1 from the exponent. In other words, if I had 0.1 times 10 squared, and I wanted to put that in scientific notation, I'd have to move my decimal point that way. So it would be 1 times 10 to the first. I would take away. So it depends on whether you have to move your decimal point to the left or to the right as to whether you add or subtract to that problem.
Okay.
Notice that in our previous problem, we had 56.07 times 10 to the minus 7th. So I have to move my decimal point to the left, which means I have to add 1 to the exponent, and that's what I did. When I added 1 to minus 7, I get minus 6. I don't get minus 8. I get minus 6.
Yeah, because it's negative.
Yeah. But that's the rule. And this is an easy rule to forget. I deal with scientific notation so irregularly. I probably only deal with it a couple times a year. And sometimes I'll forget which way it works. In other words, when you move the decimal point to the left, do you add or do you subtract? Well, that's why I bring up these situations where you can always figure it out. I can figure out that situation. I know what that number is. That's 110. So if I move my decimal point to the left, I have to add 1. That's 1.1 times 10 to the second. That's also 110.
Okay.
Okay? What else you got? That's scientific notation in a nutshell.
7, in parentheses, 7.2 times 10 times 10 to the 9th power, and then in new parentheses, 9.4 times 10 to the 8th power.
All right, let's have you do this one all on your own.
Okay. So, 7.
Do it in steps. Don't try to come up with the final answer in one step. Just do the number part, do the tens part, and then convert it.
Okay,
So it's that times that is your first step.
Yeah, 7, 9.4 times 7.2 equals 67.68.
What's the rest of it?
And then we add the exponents for the two, for 10 to the 9th and 10 to the 8th. We add the exponents.
So what's that?
It's the same bottom term, and then that gives me 17. Okay. 10 to the 17th.
Now remember, this number has to be between 1 and 10 for proper scientific notation.
Okay, so then
which way do I have to move the decimal point?
To the left.
Okay, so it gives me 6.768. What does that mean I have to do to that exponent?
We have to add.
Yeah, you have to add. You have to add as many places as you had to move the decimal point. Let's say our answer was 6,606.8. Well, now I got to move the decimal point 2 spots. So I need to add 2 to the exponent of the 10.
All right.
It depends on how many spots you have to move it. Now, it's rare that you have to move it 2 spots because they tend to give you your problems in scientific notation. So even when you multiply these two numbers together, you're going to get an answer where you only have to move the decimal point 1 spot. What's important is to remember that when you have to move the decimal point left, you add. When you have to move the decimal point right, you subtract from this exponent. In other words, I added 1 to get 18 from 17.
Okay.
Because I went left.
All right.
Got about 5 minutes. A little bit more, even.
Okay, so 2.1 times 10 to the negative fourth, and then close those parentheses and put cubed on the outside of them. Okay, that's it.
That's it?
Yeah.
Okay. Use the rules of exponents. What do you get?
So 2.1.
This cube acts on anything that's inside the parentheses.
Okay,
It acts
so
on both that number and that number.
should I cube them all?
Well, you got to cube 2.1 for starters.
So 2.1.
You know how to cube a number on your calculator?
I don't have
What kind of calculator do you have, Brett?
I don't have my TI-84.
Okay, well then take your regular calculator, whatever one you're using,
Okay.
and do 2.1 times 2.1 times 2.1. That's what 2.1 cubed means.
So 9.27.
Now do the rest of it.
Do I cube the 10 too, or do I just...
You multiply the exponents. Whenever you have b to the a to the b, excuse me, I meant xy, then that is b to the xy. In other words, this is what I call double exponentiation. Because the b is being exponentiated already, and then you're exponentiating it again. Whenever you do that, you need to multiply those exponents. Well, in this case, minus 4 times 3 is what?
Negative 12.
Base stays the same.
Okay.
Now, there's still 10 to the negative 12.
Yeah. And that number is within 10, so we don't really...
Yeah, we don't have to adjust it. In other words, it's between 1 and 10, so we don't have to do anything to it.
Yeah.
Good thing they didn't make that to the fourth, because if that had been to the fourth, this number would have been like 16, and then we would have had to change it.
Yeah.
All right, what else you got? Definitely have time for one more.
This is in parentheses, 4.0 times 10 to the third, and then close the parentheses and put all those numbers to the fourth.
Okay, what do you get?
Okay, so we're going to multiply the two exponents, or no, we're going to multiply the 4.
Remember that 4, that fourth power,
Yeah.
applies to both the 4 and the 10 to the third.
Yeah.
So what's 4 to the fourth?
4 times 4 times 4.
You really want to have your TI-84 with you when we're doing tutoring sessions.
Yeah.
You're in an area now where normal calculators don't do this stuff very good. So you need your graphing calculator. You need something that'll let you take a number to an exponential power.
Yeah. So 256
Okay.
times...
That's 16 times 16 in case...
10 to the 12th.
Okay, now we gotta convert this because that's not scientific notation.
Then we drag our decimal point over 2.
Okay, so that makes it that.
2.56.
Now what do we do to that exponent?
10 to the 10 to the 10th.
Nope.
Right? Or to the 14th.
Okay. Now, there was a perfect example of you forgot which way to go.
Yeah.
Now, you don't want to miss those problems, right? I mean,
Yeah.
this is an easy problem. You got the hard part. You do not want to miss converting it. And yet you are about to miss that. Okay?
Yeah.
So the way to memorize it is to take a number that you know. Let's take 13 times 10 to the 1. What is that answer?
130.
Okay, so if I'm changing that into scientific notation, what did I do with the decimal point?
You moved it over one to the left, so you add one to
So
the
I have
exponent.
to add one. If I subtracted one, I would have 10 to the 0, which is the number 1. But 10 to the second is 100, gives me the same number. And that's the key. So what I'm really trying to teach you here is you don't really have to memorize these rules.
Yeah.
So all you got to be able to do is solve it for small numbers, like 10 to the 1 and 10 to the 2. Because sometimes you're going to get a problem like this. Put that in scientific notation.
Okay, so I've got to move the number to the right twice.
Not
So
twice. If you moved it twice, it would end up there.
then 3 times
Okay?
6.57, and then times 10 to this.
What am I doing
Okay,
with
so
that?
that is 10 to the 10th.
Minus 10.
So the minus 10th, yeah.
Because I am subtracting 3. In other words, because I had to move my decimal point 1, 2, 3 places, then I'm going to the right with the decimal point. That means I subtract 3 from the exponent.
Okay.
Okay? And it's that simple. When you go to the left, you add. When you go to the right, you subtract. But, you know, you're going to be like me. You're going to run into scientific notation once in a blue moon. And it's really easy to forget which way to go.
Yeah.
Always resort back to a problem where you can figure it out. What is the proper way to go? When you move left, you add. When you move right, you subtract.
All right.
Okay? All right, Britt. Looks like you have some sessions scheduled next week. I'll talk to you later.
All right. Thank you, man.
You're
Appreciate it.
welcome. Sure. Bye-bye.